Okay, let's move to the little bit difficult level, and we will discuss probability density function, probability mass function, and cumulative distribution function. We will try to understand what are they and how they work. But before that, we will try to understand what is random variable. We have already discussed this. It's very simple to understand. This x is your random variable. The possible values, for example, if we doing a random event, flipping a coin is an event. It can have 0 or 1, head or tail. The two possible values, they are equal, they goes into your random variable. Okay, so x can be representative of this whole event. Let's give the values head equals to 0, tail equals to 1, and we have random variable x. That's just a simple basic definition of it. Okay, now let's start with the probability density function. What is probability density function? A probability density function is a statistical term that describes the probability distribution of the continuous random variable. This is for continuous. And we will do the other bit, which is probability mass function, which is for discrete. Okay. Probability distribution function. A probability density function most commonly follows the Gaussian distribution, which we have already discussed. Gaussian distribution is also known as normal distribution. If the feature random variable or Gaussian distributed, then PDF also follows Gaussian distribution. So this is your normal distribution, yeah, which is also known as Gaussian distribution. So in my previous video, you must have seen this about the Gaussian distribution. We have covered this topic. If you haven't watched, go watch that first and then come back to this one. Now, how do we represent probability density function? So f of x is equals to probability of x is greater than equals to a less than equals to b equals to integral of a lower limit to b function of x dx is greater than equals to 0. This is how you represent the probability density function. Now let's see probability mass function, PMF. These things do also come for your MCQs as well. Like a basic definition, like is which one is for the continuous. So probability density function is for the continuous. So do remember this. This is for the continuous. Probability mass function is for the discrete. Okay, let's understand with the definition. PMF is a statistical term that describes the probability distribution of the discrete random variable. Okay. People often get confused between PDF and PMF. Even I get confused when I'm reading it, like, most of the time PMF, PDF, like which one I'm talking about. But it's always better to learn these terms with the full pronunciation, full name, probability mass function and probability density function. Okay. There is another technique. Remember CD, C and D comes together. So what is C? C is continuous. Okay, C is continuous and D stand for density. So whenever you see D, do remember it's C, CD, C is continuous. Okay, let's go back to the definition again. PMF is a statistical term that describes the probability distribution of the discrete random variable. People often get confused between PDF and PMF. The PDF is applicable for continuous random variable, while PMF is applicable for discrete random variable. For example, throwing a dice. You can only select 1 to 6 numbers, countable. So for example, if you see this, this is your one, so this is your dice, yeah? On your dice, you have 1 either, or you will get 2, or you will get 3, or 4, or 6, for example. This is 4, yeah? So you will get only 1, but the probability of this is how many times you can get 1. So if you have 1 dice, the probability is 1 over 6. If you have, even if you got 4, yeah? If we, like, how many times you can get 4? Again, the probability will be the same, 1 over 6, because you can only get once. How do we write this probability mass function? P of x equals to P in the bracket, capital X equals to X. What is this X? X is this. you will get either 1, either you will get 2, or either you will get 3. This is your x represent the data. The probability of x is equals to the probability of x equals to the one specified x. Okay. Now let's see the cumulative distribution function. Cumulative distribution function is addition of the both. This we have already seen. Probability over here. This is probability density function. This is cumulative. So this is your normal distribution going on over here, and this is your cumulative distribution. Okay, let's understand with the definition. PMF is a way to describe distribution, but it only applicable for discrete random variable and not for the continuous random variable. The cumulative distribution function is applicable for describing the distribution of random variable, either it is continuous or discrete. Okay. For example, if x is the height of a person selected at the random, then f of x is the chance that the person will be shorter than x. If one function of 180 centimeter is equals to 0.8, then there is a 80% chance that the person selected at random will be shorter than 180 centimeter, which makes sense. Equivalently, a 20% chance that they will be taller than 180 centimeter. That also makes sense. So this is your normal distribution, and this is your cumulative distribution. Okay. So this is how you define your CDF, cumulative distribution function, CDF. Okay. So we'll stop over here. We'll come back again and we'll go further.